All right, guys, here's our new entry. It's solving multi-step equations. It says it's a foldable. Don't do it as a foldable. Just glue this in your notebook whenever we're done copying the notes. As we go through these notes, you need to follow along and solve your equations just the way that I'm doing them on here, because there's so many steps, and if you skip a step or you rush through and you're not careful, then you can make a mistake. Okay, so make sure that you're following along really close and careful. Also, be aware of your signs. Make sure that you're paying attention close to your signs. All right. Okay, so the date that we're going to use for this is going to be 9/16. So let's go on and get that in. 9/16/15. Okay. And that's it. I'm gonna move mine up. Okay, so it says solving multi-step equations. So here's our first example. It says 5n, or 5 minus n, equals negative n minus 2 plus 3 over 2. Okay, so first off, we're gonna call this step 1. So I forgot to write them, so you're just gonna put step 1. It says rid the equation of any funky fractions. Remember to multiply by the denominator on each side of the equation. So right now, this is what we call a funky fraction, okay? So we can't really do anything with this because we've got this 2 as our denominator. So what this is telling us to do is to multiply this side of the equation by 2 and multiply this side of the equation by 2. Okay, so let's look at our denominator. Our denominator is 2. So in order to get rid of the 2 on the bottom, I need to multiply this side times 2, okay? And then I'm also going to need to multiply 5 minus n times the 2 as well, okay? Okay, so now that I've put multiply by 2 on each side, I'm going to cross simplify these or cancel these out, because divide by 2, multiply 2, those cancel each other out. And then over here, I'm going to need to distribute this 2 times that 5, and then distribute this 2 times that n. Okay, so I have 2 times 5 minus 2 times n. So 2 times 5, that's going to give us 10. Okay, minus, and then 2 times n is just 2n. Okay, and that's going to equal negative parentheses n minus 2 plus 3. Now, right here, and let me get the laser. Right here where there's this negative, there's not a number there. But just like in front of this n here, there's an imaginary 1. There's also an imaginary 1 right there. So in blue, I'm going to put a 1. So basically what this means is I'm doing negative 1 times n minus negative 1 times 2. Okay, so I have 10 minus 2n. This should be an equals. I'm sorry. Equals negative 1 times n minus negative 1 times 2 plus 3. So we're going to go ahead and multiply those all together. Okay, so now we have 10 minus 2n equals, well, negative 1 times n is just going to give us a negative n. If you want to put negative 1 in, you can, but negative n is fine. Minus negative 1 times 2, that's a negative 2, and then just bring down our plus 3, excuse me. That is not part of the distributive part because it's not within the parentheses, so that just keeps getting added along. Now in class, I told you that this was a double negative, so we don't want to use that double negative, so we're going to change that and we're going to make it plus. So it really is negative n plus 2 plus 3, okay? So let's go ahead and bring that down so we can combine our like terms, because if you look right now, we've got a constant on this side of the equal sign and a variable, and then over here we have a variable and our constants over here. So we need to do some combining of some like terms, all right? Okay, so I've just brought the problem down where it says 10 minus 2n equals n plus 2 plus 3. I changed it to where it has plus 2 instead now, all right? So I'm going to take my pen and I'm going to put a circle around my constants that I've got. Now remember, right now we're can't really do anything over here on the left side to combine because there's not really any terms that I need to combine just yet, all right? Because we have one constant and one variable. So we're not going to do anything on this side, but over here we've got a variable and then we've got two terms of constants. So I'm going to go ahead and circle my plus 3 the best that I can, and then circle my plus 2 because those are both constants. And then I'm going to put a box, or try to put a box, around my negative n. Okay? So we're going to bring this down, which basically means that I've got 10 minus 2n is going to be brought directly down. Okay? So I'm going to do, so now I'm going to combine our 2 plus our 3. So I've got my negative n right here. All right? And then I have plus 2 plus 3, so together that gives us negative n plus 5. Whoop. Okay, so I have 10 minus 2n equals negative n plus 5, okay? And there's nothing we can do. We've combined both, on both sides of the equations, we've combined all the like terms that we can combine. All right, so the next part is we're going to need to move some variables and some constants around until we end up with a variable on one side of the equal sign and the constant on the other side, so we're able to solve for our variable. All right, guys. I just realized something. Before we move on and we start moving the constants and the variables around, I realized that I forgot to start writing the steps. So if we have any funky fractions, that's going to be your step 1. Step 2 is distributive property. And then step 3 is going to be combining like terms. Now step 4 is where we're going to go and move our variable terms and our constant terms. So like it says, move variable terms to one side of the equation and constant terms to the other side of the equation. So a little helpful hint is when you go to move the variables, the best idea is to move the smaller one, okay? So what we want to do is we want to move our smaller variable. So if you look, okay, which one of these, which one of these is the smaller one, negative 2 or negative 1, all right? Negative 2 is actually smaller than negative 1. So what I want to do is I want to get rid of this, okay? Now I'm going to go ahead and draw my line down right here to separate my equation out so I don't get anything mixed up. So remember, when we're trying to get rid of something on one side of the equation, we've got to undo it, all right? So in order to undo subtraction, like right here, I need to do the inverse, which would be to add. So what I would want to do is I would want to add, all right, plus 2n. Okay? And then what happens is those will cancel out. Those zero out. So then I'm going to come over here, and I'm going to write this as nice as I can, plus 2n. So basically this means that I've got a negative 1n plus a positive 2n. All right? So negative 1 plus 2, that's going to give us a positive 1 because our signs are different, so we're going to subtract. So that just gives us n. Okay? And then I got plus 5. Okay? And that equals 10. All right? Whoops. Let me finish it up. All right? So now that we've moved our variables over, now our variable terms, now we need to move our constant terms. Remember, we've already moved n over to where it's over here. So we need n all by itself. So that means I need to get rid of this plus 5. So in order to get rid of this plus 5, I'm going to want to get rid of this right here and do the inverse, which the inverse would be to subtract 5. So let's do that now. So, excuse me, I don't know what this is right here. All right, give me just a moment. Okay. All right, so I'm going to go on and subtract the 5, and that cancels out, and I'm going to do that over here. And then 10 minus 5, well, is 5. So therefore, n equals 5. And I'm going to go ahead and just type that in really quickly for you so it's a little bit more appealing to read. All right, so therefore, n equals 5. All right, now there's a fifth step where it says to isolate the variable to solve the equation. On this one, we don't really need to do anything. We've already isolated and moved everything because when we moved our terms to get them from one side to the other, we were able to isolate our variable. But what that means is, say for example that this had been like 15, this was a 15 right here, and this was a 3, then we would need to divide, all right, by 3, and divide the 15 by 3, and then we would have solved for it all by itself, all right? So that's just one example. I've got several other examples that I'm going to walk you through. Okay, we'll probably do two or three more in the notes, and then I'm going to leave one blank. If you get the answer correct, then I'll give you some stamps in class when you'll come to class tomorrow. All right, so let's go to the next page of our notes.